Okay, good morning. We'll see one tutorial. Okay, tutorial problem on the duration what you did on 2-degree freedom system. Okay, so this is the application wise problem. Okay, we'll see what it is. Okay, first determine the pitch angular motion. Okay, that is pitch angular motion and bounce up and down linear motion frequency of an automobile with the following data. Okay, there is a car. Okay, automobile car. Okay, so it is having two motions. Okay, one is pitch, that is this angular motion. See here arrow is there, no, like this pitch angular motion, angular motion. Okay, then bounce. Okay, bounce means vertical motion. Okay, that's what he is given. Okay, this is a car automobile. Okay, so we are considering it as a 2-degree freedom system. One is bounce, another one is pitch. Okay, and it is consisting of two mass, first mass and second mass. Okay, the mass kg 100 kg. Okay, radius of gyration r is 0.9 meter. Distance between the front axle and center of gravity. Okay, front axle. Okay, and center of gravity L1, it is 1 meter. Okay, distance between rear axle and central gravity, that is 1.5 meter L2, from here to here. Okay, that is given. Radius of gyration is 0.9. Okay, next front spring stiffness. Okay, front spring stiffness is 18 kilonewton meter. Okay, this stiffness. Okay, then rear spring stiffness is 22. Okay, that is 22 kilonewton at the back. Okay, we are considering only two springs here. It is a half car model. It is called half car model. Okay, since we are considering out of 4 wheels, we are considering only 2 wheels. That's why it is called half car model. Okay, now we'll resolve what are the forces occurring at this model. Okay, so whenever the problem is given, or whenever you are designing something or you are analyzing something in a practical situation, what you have to do is first write down the schematic. Okay, once you write down the schematic, write the whatever the given data is there. Okay, then you check what is the finding, means what they are asking to find out. Okay, then you go for simplification of that schematic model into what are the forces acting on it. Okay, what are the reactions are there. Okay, what are the motions are there. Okay, you have to break it down into a simplest schematic. Okay, simplest diagram. That diagram is called free body diagram. Okay, how forces are acting and how they are going to move. Okay, so that free body diagram is given here. Okay, this is when the car is in rest position. Okay, when it is start to moving, it is start to bounce and pitch. Okay, when it is start to bounce and pitch, we have to check what are the motions are there. Okay, now see, when it is pitching, okay, it may go down here and it may go up here. Okay, so let us consider it is going down and it is going upside. Okay, whatever the deflection is happened, angular deflection. Okay, that is called theta. This theta is called pitch angle. What it is, this is called pitch angle. Okay, whatever the displacement happening from vertical motion, this is called bounce. Okay, now we'll see what are the forces due to theta and bouncing in the front wheel and rear wheel. Okay, now we'll see what are the forces. Okay, see, first force, that is what is the force induced in the springs, that is for stiffness into displacement. Okay, now I want displacement at these two springs. Okay, at front spring. Okay, what is the displacement, xt, whatever it is vertically is happening. Okay, then l into theta. Okay, l into theta. Why you taken l1 into theta? Because this is angular motion. I want what is the length of the deflection. Okay, so how to find out l1? Okay, at distance, radius into theta, then you will get arc. Okay, so same thing. So vertical displacement is there, I need angular displacement. Angular displacement is not theta, as a angular theta is pitch angle. Okay, pitch angle, it is not displacement. Okay, angular displacement only we will get when we multiply it with the the L1, whatever the distance is there. Okay, from this point whatever the angle is happening, okay, this also theta, here also theta. Okay, so first one is bounce minus angular displacement. Okay, angular displacement is length into whatever the theta is there, that will become. Okay, so the total displacement at the front wheel is vertical displacement minus theta. Okay, so L1 minus xt minus L1 theta t. Okay, so this is the displacement happening at front spring. Okay, so when I want to find out what is the force, so I have to multiply with the spring constant. Okay, so spring constant stiffness is equal to into displacement is equal to force. Okay, so similarly I have to find out what is the force acting at spring 2. Okay, how to find out that, we'll see. Okay, now you see xr is equal to xt plus L2 theta t. Okay, so it is going down. Okay, so it is in angular. Okay, like this. So when it is going down, so you have to take positive. Okay, see the length L2. Okay, and angular displacement. Okay, how much angular uh, theta. Okay, how much it is displaced. Okay, so L2 into theta. Okay, plus xt. Okay, so from this point, okay, it is moving this side, right? Okay, so xt is already here. Okay, then it is moving to certain amount downward with the angle. Okay, so you have to add it here. The displacement is downward and it is moving upward. Okay, so that you have to negative it. Okay, that's why you take a negative here. Okay, now if you consider, okay, as a design engineer, if you consider this one is going down and this is going up, okay, for instance in another time. Okay, so that time this will become positive and this will become negative. Okay, hope you understood what is the force generated in front spring and rear spring. Okay, the force is equal to stiffness into displacement. So displacement, how to find out, bounce depending upon which direction it is moving, length into theta. Okay, that pitch angle. Okay, so you got two forces here. Now we will simplify the equation of motion. Okay, now let's write two equation of motion since this system is a 2-degree freedom system. Okay, now summation of force is equal to mass into acceleration. Okay, you know that according to Newton's second law, force is directly proportional to acceleration with a constant m. Okay, now mx double dot. Okay, what are the forces acting here? Okay, now front spring force and back spring force. Okay, now minus kf xt minus L1 theta minus xr xt plus L2 theta. Since they are both are acting upward, so I am taking negative here. Okay, next. So mxt, so here simplify kf xt, kr xt. Xt will be common, so take common. So that's why kf plus kr. Okay, into xt. L1 theta, L2 theta. Okay, multiply kf here, multiply kr here. Kf L1 theta is common, take out. Theta is common, take out. Okay, so kf L1 minus kr L2. Okay, next you send all this to this side. Okay, mx double dot plus kf plus kr into xt minus kf L1 minus kr L2 theta t is equal to 0. So this is equation of motion 1. Okay, now substitute value of kf kr L1 L2. Okay, now you see mx double dot t kf kr xt L1 t. This is the equation of motion 1. Okay, now I will substitute m. M is 1000 Newton. Okay, kf is 18,000 Newton kilonewton. Kr is 22 kilonewton xt. Kf is 18. Okay, L1 is 1, L2 is 1.5, Kr is 22 kilonewton. So that is 10 raised to 3. Okay, so you substitute here. Now you simplify this. Okay, now 1000 kt. Okay, here 18 plus 22 40. Okay, here 22 minus 18, 15. Okay, theta t. Now if I substitute, you will get this minus minus, this will become positive. So this is simplified version. Okay, equation A. Now you want pitch motion. Okay, one is bounce motion. Okay, equation of motion for bounce is this, mx double dot kf plus kr xt into kf. Okay, this is simplified version of equation of motion for bounce. Okay, now we want pitch, means like this, it is going like this motion. So what is the equation of motion for that displacement? Okay, so summation of moments is equal to jcg theta double dot. Okay, jcg is polar moment of inertia multiplied with the angular acceleration. Okay, polar moment of inertia into acceleration. Okay, now we will simplify what it is. Okay, jg, okay, theta, what are the angular motions? Okay, now you see kf, jg theta, kf. Okay, this force, okay, into length. Okay, so that will become my moment. What is moment? A force acting at a certain distance. Okay, so force acting at a certain distance, okay, will give moment. Okay, also if there is a jc multiplied by acceleration, okay, this is similar exactly as force into acceleration. Okay, here only thing is jc is, instead of force we have taken jc. Okay, instead of acceleration we have taken angular acceleration, that is linear acceleration, this is angular acceleration. Okay, okay, the rest thing is same. Now you have taken, previously you have taken force here. Okay, force, and here you are getting force. Okay, here instead of mass I am taking jc with angular acceleration. Here I have taken mass into acceleration. Okay, both are same, only thing this one is in linear motion and this one is in angular motion. Okay, next, so what I want to get, this is summation of all force, this is summation of all moments. Okay, so this is first moment, dcg double theta dot. Okay, plus kf, okay, xt minus l1 theta t, whatever the previous is their force, into distance. Okay, you'll understand here, whatever the force is acting with the center of gravity gc. Okay, force into distance is moment. Okay, so I got first moment, so this is the my first moment. Second moment is kr xt into this l2 t theta into l2. Okay, this is my second moment. Okay, at the rear wheel. Okay, this is overall body moment. Okay, front wheel moment, back wheel moment. Okay, here when it is doing in the pitch, okay, one side it will be positive, another side it will be negative, because one it is moving downward, another it is moving upward. Okay, that's why here negative and positive came. But in the previous, pitch will be always same in two wheels. Okay, when it is same in the two wheels, so you will get either positive, either negative. Okay, so you have to take care of that. Now we will simplify this equation. Okay, so jc is mr square. Okay, m is mass. Okay, r is gyration, radius of gyration. Okay, you'll get polar moment of inertia. Okay, next, theta double dot t xf l1. Okay, xr l2 xt. Okay, here xt, here xt, l1 l2. Okay, so if we simplify it, I will get common xt. Okay, next is kf. Okay, l1 theta t, l1 l1 square. Okay, l1 square, kr l2 theta t into l2, so that is l square. Okay, so l square I will get theta t. Okay, next, here it is l2 xt l2, so it should be l2, it is not. One second, so kf l1 square, it is correct, k1 l1 square, so it will come here. Okay, kr l2 square. Okay, so l2 square here into theta t, okay, is equal to 0. Okay, mass is 1000. Okay, next r is 0.9 whole square. Next, angular acceleration minus kf is 18 into 10 raised to 3. L1 is 1 plus 22. Okay, into 10 raised to minus 3. Okay, 1.5. Okay, xt. Next, 18 10 raised to 3 L1 square minus 22 into 10 raised to 3. Okay, 1.5 all square into theta is equal to 0. Okay, next, so if you multiply, you'll get 8 10 raised theta t plus 22 into 10 raised to 3 x t xt. Okay, plus 67 5 theta t. Okay, if I simplify this, I will get this. Okay, okay, now you see equation of motion, so you have to substitute kf, kr, k and c. Okay, so 1000 to 0.9 square double dot theta double dot minus 18 10 raised to minus 3, that kf into 1. Okay, that is L1 minus 22 is kr. Okay, if you simplify this, I will get 8 10 theta double dot plus 18 minus 22 into 1.5. Okay, 33 minus 18, that is 15. Okay, xt. Okay, 18 minus 22. Okay, so if you simplify this, you will get 67,500 theta t. Okay, theta t you will get. Okay, you simplify and check whether it is correct or not. Okay, so you will get the exact answer. Okay, here it is theta 1.5 theta whole square. Okay, let me change it. Okay, so it is 1.5 whole square because L square is there. 1 square it is 1 square. Okay, 1.5 square multiplied by 22. So if we simplify that, we will get 60,000 67,500. Okay, we check whether it is correct or not. Okay, then let me know. Okay, next, see the next. So once I simplified, I got equation of motion. Okay, so we have two equation of motion, equation A and equation B, that is bounce. Okay, this is bounce equation, pitch equation of motion. We have derived the equation of motion for the automobile in the motion described. Okay, and let us assume the solution. Okay, xt is equal to x cos omega t. Okay, plus theta 1 theta t. Xt is this solution for bounce. Okay, this is solution for pitch. Okay, so theta cos omega t pi 2. Okay, so this is assumption. So you used to do assumptions while doing derivations, right? What is the solution, initial solution? Okay, how it is going to be here? Okay, in that you have to find out what is x and what is phi. Later you have to find out what is the natural frequencies. Okay, we'll see how to do that. Okay, so you assume that displacement, the bounce value is xt and the pitch value is theta t. Okay, now I will differentiate this because I need theta double dot and x double dot. Okay, xt I know, theta t I know, so xt is this value, theta t is this value. I can substitute theta t here and xt here. Okay, here also same thing, equation A and B. Okay, now only I need is xt double dot t, theta double dot t. Okay, so xt double dot t is, once I differentiate it, I will get x omega square cos omega t plus 1 pi theta pi 1. Okay, same thing, velocity theta dot, it is minus x omega sin omega t plus 2. Okay, theta double dot t is equal to minus x omega square cos omega t pi 2. Okay, so this is my acceleration in bounce and angular motion. Okay, I will substitute xt here. Okay, theta double dot here. Okay, xt here, theta here. Okay, so xt here, then theta here, this value I'll substitute. Okay, now you substitute in equation A and B. Okay, so substitute these two into equation of motion. Okay, will gives, if I substitute in first, 100, that is mass, 1000, that is mass, x omega square cos omega t plus pi 1. okay, plus 40 into 10 raised to 3 x cos omega t plus pi. Okay, so theta cos omega t plus pi. Okay, same thing if I put it in equation b, so I'll get this equation. Okay, so let us simplify this by assuming theta 1 is pi 1 is equal to pi 2. So this gives us, okay, here pi 1 I will take pi 1 I will take pi 2 I will take pi. Okay, so if I assume that this will become cos omega t pi cos omega t pi cos omega t pi, that means cos omega t pi is the common, so take common out here. Okay, once I taken common out here, the rest coefficients are 1000 x square omega square plus 40x. Okay, next 50 theta. Okay, cos omega t is common. Same thing, so pi 2 pi 1 pi 2, so I have taken this as uh, equation theta is equal to the pi 1 is equal to pi 2. So if I substitute pi 2 is equal to pi, so I will get pi t omega cos omega t plus pi as the common. So okay, same thing, you take cos omega t pi as common in equation 2. So when I take it, the only coefficient will remain same, minus 8 110 theta omega square 15 into 10 raised to 3 x 6750 theta, okay, into cos omega t plus theta. Okay, this is pi. Okay, written theta, you make it into pi. Okay, let me change this. Okay, now I got cos omega t plus pi as the common. Okay, so I hope you understood up to this point. Okay, next what I have to do is I have to simplify this. Okay, to simplify this, since cos omega t can't be 0 for all t values, we will eliminate this. Okay, consider it as 1. Okay, now minus 1000 whatever the terms are there except cos theta, you write it simplified form. Okay, so this is the simplified without cos pi, cos omega t plus pi. Okay, now I will write it so like this. How to write this? Minus omega. Okay, so here x is common, take out, here theta is common. Okay, here theta is here, theta is here. Okay, so here x is common. Okay, take out x, minus 1000 omega square plus 40 into 10 raised to 3 x. X have taken common out. Okay, here theta is there, so keep as it is. Okay, next what happens here? Minus 810 theta omega square 6750 theta. Okay, so theta common, take out common. Okay, if I take common, so I'll get 810 omega square plus 67500 theta. Okay, so this remains same. Okay, because only x is there, here two thetas are there, so I get simplified form. Now I will write it in matrix form. Okay, so it is very simple to write it in matrix form. So two quantities are there, theta and x. Okay, so first is x. What are the terms involved in the x? So this is the first term involved in the x, and this is the second term. Okay, so x terms you write here, so x which is equal to 0. Okay, now theta here, theta here. Okay, so what is the first theta? First theta is this 15 plus 10 raised to 3. Okay, in the first equation. In the second equation, theta is minus 10. Okay, you write in side by side. Okay, this is first equations, first x. Okay, this is first equation, second equations, second x. Okay, so I have written here. Okay, this is first equation. Okay, this is second equation. Okay, so it is very simple to write. Okay, x and theta. Okay, next, now you simplify this. Okay, now x theta, so if I remove this, I will get this. Okay, now if I simplify this, x and theta cannot be 0, so I will take it as 1, then I will simplify this equation. Okay, so when I take determinant, okay, how to simplify this matrix? Multiply these two minus multiply these two. Okay, so minus 1000 x omega square plus 40 into 10 raised to 3 into minus 810 omega square plus 670 square minus 15 into 10 raised to 3 into 15 into 10 raised to 3, so that's why I taken square. Okay, see, 15 into 10 raised to 3, 15 into 10 raised to 3, same, so that's why it is square. So multiply these two and keep. Okay, so when I simplify this, I will get 8. So here multiply. Okay, so 8, 10. So I'll get extra 3. So 4 zeros will come into 40 into this. Okay, next 1000 into this. Okay, then 40 into this. Okay, minus 10 raised to 3 whole square is equal to 0. Okay, now if I simplify this, I will get 81 omega to the power of 4. Okay, minus 99 omega square plus this value 2475, 6 zeros. Okay, so divided by 10 raised to 5. Okay, see common here, 10 raised to 5. Okay, here 5, here 4, here 5. Okay, so I'll get 8.1 omega to the power of 4, 99, 9, 999 omega square. Okay, 2475, 0. Okay, is equal to 0. Okay, if I divide it by 10 raised to 5. Okay, rewriting this in quadratic form. Okay, this is quadratic form. So omega square I have taken all. So omega square remains same, 247. Okay, now I will write using quadratic equation solution. Okay, what are the roots of quadratic equation? Omega is equal to b plus or minus b square minus 4ac divided by 2a. Okay, what is b? Minus 99 999 plus or minus b square minus 999 all square minus, okay, a 4 into a is 8.1, c is 24750 divided by 2a, 2 into a, what is a? 8.1. Okay, so if I simplify this, I will get omega 1 square is equal to 89.002. If I take root of it, I will get 9434 rad per second. Okay, so for omega 2 whole square, so 34. Okay, this is if I consider positive, I will get this. If I consider negative, I will get 34. Okay, so omega square, so if you take root, I will get 5.89. Okay, rads per second. Okay, so this is omega 1 and omega 2. Okay, since the frequency must be positive, makes sense in the real world. So we will have omega n1 is equal to 9434, omega 2 is equal to 5.89. Okay, this is the natural frequency of the system. Okay, so when they ask this question, so you have to do up to this point. Okay, hope you understood this problem. Okay, we'll explain, okay, in the simplified manner. Okay, just what you have to do. Okay, let it come. So this is the derivation. Exactly, you have to follow this derivation in order to solve that problem. Okay, okay, it is an application oriented problem, so you have to think it and you have to do it. Okay, I see. So this is an equation of motion. Once it is given, so you have to resolve the whatever the forces are there. One is bounce, okay, another one is pitch. The force is at two springs. Okay, so then you have to find out equation of motion. Okay, one is bounce, so bounce will be related to mass into acceleration. In the pitch, so it is moment jc into angular acceleration. Okay, so you should very careful in that. Okay, once you get equation a and equation b, that is pitch motion and bounce motion, you have to assume those solution. Okay, one is xt, another one is theta. Okay, it is in vertical, this is in angular. Okay, so once you assume that, you have to substitute in these two in equation of motion. Once you substitute in equation of motion, assume that the phase angle is common. Okay, then take out the common, then omega square is there and x square is there. Okay, so you take out the theta and omega, then you simplify for omega. Okay, so once we simplify for omega, you will get two natural frequencies, okay, as a roots. Okay, so from this roots we will get two natural frequencies. Okay, this is overall picture of this problem. Okay, so if you have any doubt, you can ask me. Okay, yeah.